the coordinate transformation, really, like from going from one coordinate to the other, I think it's fundamental to it. So because you have, this world coordinate versus you have your base link versus you have any other coordinate in between. So all those transformations, I wanted to actually take it and get it to the basics of it so that everyone understands that what really they're doing in, the transformations. So be it the forward kinetics or the reverse, the inverse kinetics, anything that you wanted to do, and how would you use the TF, basically, and make use of it whenever, you need it to. Because I think those are the fundamentals. And then I wanted to touch base the states, like all the machine states. So, and really, these guys have hit the really well. Like, who's this guy's that teaches the online thing? The construct guys, and they had this FlaxB today, right? They had this Flax, which is related to the state machines. It's a really important concept, and FlaxB is really a nice tool. So I think I wanted to touch base on that maybe in the future. I think that'd be really cool. So there are a couple of concepts, if you can get to it and if you understand it, the ROS becomes actually more easier. That's what I think.
Are you also going to cover like how to mount things, and then how do you set up the transform between wherever you mounted?
Yes. We starting very basic, and at least we'll have at least one simple example where you can see that how it is getting transformed from one coordinate system to the other, and why it is important, and how we can make use of it.
Awesome.
The best example that I have of doing transforms is when I'm trying to do that straight line tracking or tracking to a point. Everything becomes simpler if I can do it in the frame of the base. So I know I've seen Pure Pursuit done in World Frame, and with all the transformations kind of built in, and all the sine cosine of this and that. But man, if you do it in the frame of the base, it all gets so simple. And I really like the power of ROS to do those transforms. It simplifies the code so much.
Totally agree.
I also notice, since we're chatting, for a long time I avoided transforms. So I'm a big advocate now of people learning transforms early, because I know what I went through because I avoided it. And I remember lots of conversations where people would say, oh, well, you need to do this and that, and look at your transform tree, and well, this, of course it's not working because of this. And I would try to jump in, look at these threads, and I just thought, oh man, this stuff is so complicated. I will never understand this. But it's such a simple thing once you understand the basics, and do just static transforms. Yep. Having just a few static transforms makes a huge difference.
It is.
So I really want people to just try some things and get their feet wet with transforms, because I think if you do that and you have that tool, then you won't be tempted to try to write the transforms yourself. And I know when I did it originally, I remember my first planter, well, my second one, I was in the field and I was getting these crazy, not oscillations, but jumps. It would jump around in the middle of the field. And I was just so frustrated. And I finally thought, okay, maybe it's because I was treating everything as two-dimensional, and I wasn't taking tilt into account. And so I started working out the trigonometry for the tilt, And it's not that difficult. It's really not that difficult.
Right.
But it took me a while to get it right and to verify that I really had gotten it right. And that's the kind of stuff that is just so simple if you just have the transforms and you
Correct.
just say, oh, just do the projection onto the ground from here. So yeah, I think it will save people a lot of headaches if they just learn it up front.
I totally agree. And that's one of the things where if somebody shows it to you at the very basic level, you get the idea, and then you can actually leverage what ROS has to offer. And we'll start with like a small array, just for the basic understanding. It could be like just 2 by 2, and then we can go to the 3 by 3, and that would actually makes that would make the things much more easier to understand. Actually, that's what I think.
Are you using TF or TF2?
TF2, of course.
Okay. Well, I end up using TF and TF2 for some things because I'm doing weird stuff.
Okay.
I'm doing all my operations based on transforms. I'm a transform junkie now.
Nice.
And TF2, I had some problems with some operations, so
Okay.
I just haven't gone there lately.
Okay. Yeah. The other thing that I'm actually finding it very useful, Matt, let me know if, we're just chatting. So if you have anything else, just please interrupt. But the other thing that I'm finding it very, very important that we can efficiently deploy with all of these ROS codes, it's the NumPy. And the understanding of the NumPy and its application is amazing. I mean, I've been actually looking into it, and I'm looking at the codes, what people have written, and I think you can speed up the operation, which you can actually write it with the regular Python loop, versus if you implement the NumPy, it gives you so much power that I cannot explain. I mean, I'm literally just like the epiphany, like when I see it, it was like, oh my God, that kind of thing with the NumPy. So I really highly encourage, and I think I'm just gonna actually do that one session on the NumPy too. See if I could, because like I said, I'm not an expert, but I'm trying to learn, see things, differently. But
I think that's great. NumPy is a great example of using Python, but shipping off the really complicated stuff to efficient, probably C code, C++.
Yeah.
And yeah, it's perfectly appropriate. Have you looked at Shapely?
Oh yes, absolutely.
I will recommend Shapely. I think that's another really good toolbox. If you can use it instead of custom code, you're way ahead.
Correct. So your proper combination of Shapely and NumPy would give you actually really far, because all the geometric operations that you wanted to do it through the Shapely, but you wanted to use the array and the power of the NumPy, so that you can do the efficient operations really fast.
Yep.
Just amazingly fast, and then you just forget about the loops, avoid the loops, the regular Python loops as long as you can. I mean, in your prototype, that should be fine. But consider whenever you actually write a loop, consider that if you can actually replace it with the NumPy whenever you're actually going to the second and third iteration.
Yep, I agree.
Solid. It's like I'm looking at the powers, and like I said, this like totally, oh my God, aha moments, like every time. So, and I explored the tmux. I recently wrote up like a page for the tmux and how to use it for the ROS. So I have that coming up. Probably I should be able to post it this weekend.
I still use screens, so I'm going to come to you for tmux help. I've tried to switch a couple times.
It's really simple, really cool. I love it. And then I think I can put it in ROS context, that how we should use it for the ROS, and I really like it.
By the way, I start screen sessions from systemd on boot. So I start ROS core in its own screen. I start do my launch file, my main launch file in another screen, and then I can I can pull out pieces that I want to work on in different screens. That works really well for me because I can SSH into it and then jump into a screen and stop it and start a component with a modification.
Yeah.
I think Tmux is going to be even better once I get onto it.
It's super easy once you know it, of course. Super
Yeah,
easy.
I just have key combinations that I've finally gotten ingrained for screen, and
Okay.
it's hard to switch. Old dog.
Yeah. That'd be really. In my I just posted like last week or maybe 2 weeks back how to create the iOS package, and I have used the Catkin_tools, the new Catkin, not the old Catkin. It's really nice. I mean, just take a look at it.
Oh, great.
Yeah.
Matt, do interrupt us anytime. Are you using ROS 2 at all?
No, I'm not. No.
I really want to try that. I'm gonna make the jump here sometime.
Okay. Yeah, I mean, there are not a lot of libraries there for the ROS2, and that's probably one of the things. I'm not sure if all the main libraries are there and you can get away with those, but I think ROS2 is robust. That's what I'm hearing.
Say that again.
It's robust, like it's the professional grade. It's like it's industrial.
Well, I don't use much from ROS. I use it more as a message passing environment anyway. So I figured I might as well switch to ROS 2 and start to build up what I need there. But yeah, I'm looking forward to it.
If you switch it right now, you're probably light years ahead. That's good for us, so we can learn many things from you then.
Oh boy, it'll be a while. You can at least learn where I make mistakes.
Well, and that is very important because that's where anyone and everyone can get the guidance and the direction that where you need to avoid these things and then you need to learn these things. And so don't avoid TF right now, like how confidently you say that, right? And me now say don't avoid it, learn it. It'll be easier. So I think it's our job to make it probably easier to understand. If I could, I would, and that's what I'm trying to do.
Matt, you want me to talk about InfoAg at some point, and I'll do that. I'll hold off.
Anytime. Chat session. There's no presentation tonight.
Oh, okay. Well, I'm going to try to remember. Okay, I've been at InfoAg in St. Louis, and today there was a track for 2 hours on robots, and it was Scott Shear of Ohio State University, OSU, and Mark, who was a consultant and knew more of the international robots situation. So it was a very interesting presentation. Afterward, I got to talk to a few people, and one person who approached me, and I've got to get his card out, but he's working on an ag robot, or ag, I think it was more general, ag technology program in California. And we were talking about robots, and I said, oh, do you know about ROS? And I'm part of ROS Agriculture. He had heard of ROS. I tried to impress upon him that this is the way to go, that we have standards, that we have all these tools. He's trying to teach students how to do things. He came up with the example of if we can give students the ability to know where they are with GPS and be able to move an actuator or control a motor or something, that gets people really far. And I wholeheartedly agree that those simple tools, we've seen that. I saw that with Al. I think we got Al to move a linear actuator through ROS, and what a great introduction that was. And so I tried to tell him my impression of ROS Agriculture being a place to work through some of the holes in ROS, like what I have seen of typical ROS. People think of GPS being noisy, first of all, where if we're using RTK, that really changes things. We don't use wheel odometry so much, typically, and then just driving straight lines instead of trying to home to a goal. Those are three things that are very different from typical ROS. So anyway, I got him. I think I got him interested in it, and so I'm looking forward to ROS agriculture, working through things and developing some tools, and I want to help do that. And that's one of the reasons that I'm kind of back and forth about switching to ROS 2. I want to make sure that ROS 2 is where it's helpful. I don't want to mislead people. I don't want to say, oh, well, everything we're doing is in ROS 2. However, there's not much going on in ROS 2. So if you take this path, you're going to be kind of on your own as far as ROS packages. So I'd like for someone to say, I'd like for someone to tell me that, no, ROS 2 is going to be fully supported someday soon and have all the packages that everyone needs. Otherwise, I feel like I should probably stay with ROS so that it's easier for other people to follow what I've done. Other than that, InfoAg, it's pretty amazing. People wholeheartedly want field robots. Everyone expects it. I had a meeting yesterday also. People are expecting field robots, and I talked about how I just read an article that said we're going to see field robots at a 30 or automation, full autonomous at 30 to 50% more than current tractors. And of course, I see it as they should be 30 to 50% less than the manned tractor, because you're getting rid of a lot of equipment. You get to redesign it. And the people I was talking to were totally on board with that. That's what they were thinking too. So field robots are really, everyone that I've been around lately has been just assuming that they're coming and that's how we're all going to do things. And if you can't do that, if you're a farmer who insists on sitting on in a tractor, you are going to be overtaken by people who are more efficient. So we're right in the middle of it. I think that's all that I have from InfoAg. I'll see if I can remember something else.
That's great. That's interesting that they are assuming that the tractors are going to be for sale. I think hopefully next year we'll start to see some autonomous tractors for sale.
Well, they mentioned, let's see, in the presentation, there was the example, of course, DOT is available for pre-sale right now, I think, and it's out in pilots. Bosch was one that was mentioned. I forget the name of their robot. I would know it if I saw it.
Bonnie Bob or something.
Yeah, Bonnie something. Yeah.
Bonnie Bob.
And yeah, they said it was really expensive, but it's available right now at more of a research platform. So those are the ones that I remember being readily available. Didn't mention, what's that? Oh, they didn't mention Smart Ag, but I know Colin has been doing pilot programs. In fact, I met with one of his testers. So Smart Ag, they're, I guess, early release, but I would say that they're almost on the market. And I know that there are some orchard robots that have been around for years, but I'm not so familiar with them. So it's here, and that was one of the bullet points. Field robots are here. They are out now. More are coming. In fact, that was one of the topics that, well, the heading was tens of thousands, and so if you include the aerial drones, yeah, you get to tens of thousands. But even the ground robots, what I call the field robots, they're proliferating. That was the word that was used. And so we had one person, Scott was talking about, from OSU, was talking about kind of general, especially what was in the U.S., and Mark talked about non-U.S. development, and there was a lot going on out there. It was especially interesting to me that Mark talked about how it takes this cluster of developers to make field robots, and I thought about how we're all doing it on our own. So, but I granted we're not bringing it to market yet. But he pointed out a few places that are likely to become, or that have all the people, the infrastructure to become this cluster that would develop ag robots. St. Louis was one of those places that was interesting to me. Yeah, one of my questions to them, or my one question to them was, do you see any standardization taking place, or are these field robots going to be just closed systems? And I didn't get a real satisfactory answer. The answer was they expect those field robots to kind of standardize on standards from other industries. And I take that to mean it's going to be stuff like J1939 and ISO 11783, which I take to be, that's a very different level. ISO 11783, for example, sure, you can tell the hitch, for example, to move to 50% height. You don't know how high that is. There's no definition of how high that is. And robots need to know how high that is. So I feel like the difference between that and ROS with transforms and frames, there's just such a huge leap there. So as far as I can tell, no one's talking about using something at the level of ROS to control all these robots. I'm sure lots of them are using ROS, but there's such a need for an infrastructure. There was talk of what I've been pushing for quite a while of using these field robots as a service. So much like people in specialty crops, they see weeds in their field, they call a company and say, go weed my field. And they bring in, they were giving the example that a truck shows up, brings porta potties in. Another truck comes up, they bring workers in. The workers go out, weed the field, and then leave. The farmer or the landowner never sees it. And so you could convert that to field robots doing the job, and it would be transparent to the owner or the farmer. But I see things like in row crops, so I'm familiar with row crops. I really want to have a way to say, here is my field as I planted it. Here are the exact rows, like we talked about last week or the week before. Here's where the planter actually planted. Sure, here's my AB line. Here's where my tractor drove, but here's where my planter actually planted. So if you're going in there to do side dressing, for example, you want my map so that you know exactly where my plants are, so that you don't run over my plants when you're following the AB line, for example. So I know that there are lots of ways to do that. There's field view. There's I talked with Ag DNA today. And there's Fuse from AgCo. Everyone has their own way to save that kind of data. Well, some of them have a way to save that data. But I don't feel like there are standards out there for even handling that data so that we can start using these services interchangeably. You're going to get locked into a system. So anyway, I think there's a lot of opportunity for Ross if we develop some tools and say, hey, this is the way to do it. And you need to conform to this. I don't know that industry will do that, that they would conform, but it would sure be nice to have some standards available at least for some data interchange like that. That's a lot to bite off, but it's certainly a need right now.
I totally agree with your point that we need a standard, which is just common across. And right now, whoever's going to take the lead, will help develop the standards and probably move forward. So, remember, I had this presentation. I think it was in March or April, when I mentioned that the data standardization is very important, and the GODAN, G-O-D, and it's just one of the international kind of nonprofit organization, which is actually taking this forward. They're like have a global outreach. They're actually the biggest advocate, of the open data, and also they would probably help making the standardized data format across, the probably not just in one country, but across the countries. And it would help spread that too. And then I think that's just one of the good platforms that I came across. We all speak one language, so be it if you have the proprietary systems, fine. But if we all speak one language, it means that data transfer would be much easier so that I can, if the data is coming out from the proprietary system, and if I wanted to digest it, I should be able to do that. That's the whole goal. Like it has to interoperate. It has to talk. System has to talk with each other. So be it it's the proprietary system or the open source system. I don't think that we have that at this point. And ROS agriculture can be a key, the advocate in order to take that further and, approach it in that way. Teach people, to have the standardized data so that, at least companies will have a port where they can say that, oh yeah, if you need this format, here's the standard format. You can spit out the data in that format, and then take it to wherever you want. I agree with the data part. I agree with the standardization of the data and the one format, but I don't see it happening around at this point with the proprietary systems at this point, at least. So there is no common format.
I would love to see someone propose it. I think at some point, I would like to see for that that example of someone's specialty crop, they say, or something, a drone goes out and says, we need to weed this field, and it goes out for bid automatically. All the descriptions of the field goes out for bid, and then you get bidders back, and it can just happen so automatically. Someone's going to do that, and they're going to make it all proprietary, I feel like, and then it becomes a very small system.
Exactly. Yeah. I would love to see traction in that area, and not just, internationally, not just the locally or specific to the region. It just because ROS is just a global community, and it means that if we have certain global standards, it will help not just few countries, like everyone who just wants to use the ROS for the agriculture, at least.
Do you have any sample data? I mean, is there anyone else that's actually recording each of the plant locations? And can we get some of those data sets to take a look at what we might use in ROS, how we could?
I know that AGCO talks about it with Zauber, their little single row tiny planter. They talk about plant by plant. I forget how they say it, but they're certainly thinking about it. But I have seen nothing as far as data formats for that.
And I haven't either. I mean, I totally have not seen that. I mean, they're using their own proprietary, the formats. Just nothing that goes across the board, that where you can see that, oh, this is the format. I know that, I mean, right now they're IDing it as if, they're like an IP address, so that's how they ID it. They assign the IP to each individual, the crops and plants and stuff if they're going by the plants,
That would be interesting to put together something for the ROS users to use. If there's another package or if there's another application where people are storing data, maybe we could take a look at how that project is doing it. And if we put it out there, maybe other people will start to use it.
Yes.
I think just starting with something, what is GeoJSON, QGIS, there are some data formats that take what I think is a lot of data, and they're made to handle much bigger data, much bigger geographic data. So if we can start with something that's really overpowered for what we're talking about, I think that's much better than trying to go from something that is like ROS point clouds, and storing data like that. It feels like that might be much more of a ROS solution, but it's not going to be powerful enough for what we need to do eventually. So someone with experience in the geo database realm, I think they'll look at this problem in a much different way.
I'm glad you're talking about that, but so I was actually looking into it last week, and I have some notes over here where it's what you're talking about is the one of the QGIS, it's like obviously the geographical information system software, but the libraries and the packages where we should be taking a look into, it's osgeo.ogr, and then there's a osgeo.gdal.
Yeah, I've used that.
And there's a CGAL, obviously, and the format could be any, the geo information format, which is, like you said, GeoJSON, or it could be KWKT or KML or KMZ or any format or shape, for that matter, the shape file could be any format, which is like the standard open source formats, or maybe the standard formats, like a standard protocol. Yeah, those are like really good. And then there's a Postgres, the SQL, the adapter, which is the PSYOCOPT2, which is the library that supports it to the Python, so that you can actually use that if you need it to store it in terms of database. Sort of things, like, so I think you're probably the right direction. That's what I was actually thinking last week, and I was exploring some of these formats and data, actually. I'll post the link.
But by the way, I did talk quite a bit to a company called Soil Optics, OPTIX, Soil Optics. They make a gamma ray sensor. It's like a $65,000 sensor that you put on the front of a vehicle. That would suck to run into something. And they do soil mapping with that, and it's very interesting to me. But they're running a Windows program that collects the data and then uploads it to the cloud where they do all their processing, and then they send it back as a shapefile. That feels right, and they're working on their program. I would love to be able to say, hey, how about putting it in Postgres, something, some kind of database, or maybe we just take it from a shapefile and push it in. But there's got to be a little bit more streamlining of this. It seems like everyone's depending on, oh, well, you can just connect to it from your tablet and then do a download, do an upload here, and then you do a TFTP or a FTP download somewhere. You know, it's like it's still in this batch mode where everything is very manual. But for people who are only doing a few acres, I guess it's not that big a deal, or I don't know. It just seems very clumsy. And if there was a way to say, hey, we all need this standard, just do it. I think that there are people who are just getting started who would go along with it.
Have you had any luck working with the shape files? I know that, is that a standard from Esri, or is that open?
Yeah, it's fairly open. I use it. I have used shape files. So I do a little work for a company that has an autonomous soil sampler, and they were doing all their routing by hand. And I said, no, let me automate that. Shooting off my big mouth. And so I just did an example. And it turns out they were given, the farmers provide them with shapefiles. And I found out how truly ugly shapefiles are. Shapefiles are this standard that's evolved over time, and it's a zip of multiple files. Oh, it started with something, and then they realized they needed something else, so they just added another file and another file. And it's just ugly. And interpreting them is really difficult, but there is a Python. There's a Python library that I use, and I can't remember it right now, that you can definitely do shapefile manipulation. So I would much rather use GeoJSON. That looks like the winner right now, but there's also KML. So I think if you can avoid shapefiles, that's great, but there are definitely tools to do it in Python.
I think the JSON seems pretty reasonable. You can move data around. That's a pretty standard format. It's open, it's clean, light. I don't know about moving. Like if you had every location of a corn plant, for 100 acres, isn't that, how many plants are we talking?
So my example of corn is something on the order, sorry, Colin, I'm gonna use imperial measurements. You're talking about 30, 35, maybe even more thousand plants per acre. If you go to beans, you're talking a few times that, so 130, 150,000 plants per acre. So it gets big, and JSON seems really wasteful at that point. It just seems like a lot of extra,
overhead,
very compressible, redundant information.
brackets.
Where shape files, it's basically a CSV file that you're coming down to. So from that perspective, yeah, I get it. I get the shape file. If you're looking at a single interchange, the work I did, where if you can do all the zip manipulation and all the shapefile manipulation, do it all in Python, and if it's a consistent thing, so you're getting it all from the same producer and they're doing it in a very consistent way, shapefiles are perfectly fine, perfectly digestible. It's just that there's so much room for variation. If you've got different people generating different shapefiles from different programs, there can be a lot of variation.
Plus, you have the open source programs which would convert shape format into the other formats. For example, QGIS can do it, and there are lots of other programs. I think there are Python libraries too that can convert the shapefile. So if you come across that, if you ever have to convert it, I think you can do it.
Yeah, I got into problems where the ID of a single point might be defined several different ways. It was crazy, the difference in data, and it was just different programs were used differently. And I suppose you might be able to do something screwy like that in GeoJSON, but I think it would be less likely.
Right.
I have a question about the discussion that we're having. So I was thinking that is it totally necessary to include lat long information about where the plant exactly is? I mean, can't that be done on just a map of the farm itself rather than pinpointing it on the on the map of the earth, instead of doing that, having it from, so I'm not being really clear because my thought is not that clear, but what I'm trying to express is, let's say we have a square map, like a square mile. If I was looking at Earth's curvature and other stuff, I was just on my train of thought, and it doesn't curve as much. The Earth doesn't curve as much. And then I looked at the average farm size, and it says in America it's 450 acres. That's an average farmland. That's how big an average farmland is. So I was wondering if we can just have an outline of that farm on a flat map that does not curve, and then just pinpoint, I mean, use data points for those, for just for where the plants are. It would save on, accuracy as well, because if you're looking at lat longs, they go really high if you want higher accuracy. So in decimal places, yeah.
I think I can address a few points. First of all, 450 or whatever, think about field size versus farm size.
Right.
That average size, a good size row crop farm is going to be like, or operator is going to be, let's say 3,500 acres or more.
Oh, okay.
But their fields might be 40 or 80 acres, and you wouldn't want to do one square to encompass all of them. You're going to want to do it by field, because some of them span long distances. But that's what you're describing, I think, is how it's done today by most everyone as far as coverage maps go. So they basically kind of plonk down, oh, you planted here. This row was planted. But there are layers of that I think are important. So I really want to capture for each seed, I really want the precise position. And you're right, that saving the latitude and longitude of each position is costly, but you can do it as, there are certainly ways to make it more efficient. So like set X and Y to 0 for some point in your field, some corner, let's say, and do offsets from that. There's got to be a way to compress it.
That's exactly what I was proposing.
Yep.
Instead
Yep.
of, yeah.
So there's definitely that, but also realize that there are lots of layers. So I want to know, for example, what my speed was at that point. I want to know how I had my depth set. I want to know, now there is data coming back of what soil properties. So there are sensors in the planter saying, here are some qualities about the soil. I talked to people today, we talked about putting more sensors. So picking up lots of chemistry, lots of soil data from the planter. So there's all this data that goes along with it, and I guess that those points would not necessarily coincide with the places the plant was put down. But one of the reasons I want to know exactly where the plants are, and I think you were not saying don't keep track of that, just do it differently. But it's important to me to know that I can go back and say, oh, I had a double there. Current programs will say, oh, you had poor singulation in this area, or you had doubles in this area. But I want to know exactly where they are. And in fact, there are, like lettuce, they overplant and then go back and thin. So they kill plants. And I think it's useful if you have all that very exact data. You can start doing calculations of where you might be killing plants to thin them optimally. It also, it seems like a real simplification. We talk about doing, like with AgBot competition, there's all this effort going into detecting weed versus plant. Well, what if we know the exact location of every seed that went in the ground? Now you say, well, only things there are plant. Everything else is weed. And that simplifies it too. So Sohan, I think you were saying more, let's change the way that we store things, but I just wanted to address that right now companies are doing this coverage data, and it's really this low precision data. And I think it's more important to get to the high precision. I think it's less important to work at making it highly compressible or doing the compression ourselves, because something like Postgres is just going to take care of it. They know how to do it. So it's not worth, I don't think it's worth trying to pursue that right now, although I could be wrong. Did I address anything you were thinking?
Yeah, sort of. So when I was thinking about what the problem here was, and I might have gotten it wrong, but I thought the problem here is that there's no standard data. Like, we don't know, like everyone does it differently. So, and then the solution to that would be to just have a map format that would be a standard. And then all of the data that you just suggest, because while you say all of that should come, or I might have gotten you wrong, but what I understood from what you said is that all of these information that's coming from the sensors currently and the new sensors that you talked about, all this data needs to be unified. But I think all of that data needs to be unified. I mean, it all unifies with just a position. So let's say the data that you're getting from your soil sensor, once you realize that that data point was something you got from the position 5,5, 5,5 something or whatever, from your personal map, all you need to do is to have that standard map of your field, so then you can use those different data points, because I would think that not all farmers would have all the sensors that we are talking about. Some might not. Yeah.
That's true. So in and I think this is more of a localization thing. Like if you have your own 2D, the coordinate system, and then you always want it to be local within that, you can do it. And then you can have your own format, how you actually locate the places in your farm. But let's say if you want it to be in GPS coordinate system, because it's like worldwide, and then this formats, for example, any of the GIS systems format, standard formats will give you the options to use the layers and stuff, so that you can have, in one layer, you can have one system. In other layer, you can keep some other kind of data. In third layer, you can have the map data. You can have the zoom in, zoom out data. And that's all standard. So it means that you have more integration and it would look more natural, and you don't have to actually reinvent the wheel. So-called, if you wanted to lay, the flat, so it means that what you're looking at, remember your nav set, that your transform node also will spit out the UTM coordinates. So if you're really interested in UTM coordinates, which is like kind of an X and Y, you can also do that. But obviously, you would have the good GPS or maybe even RTK that would give you the accuracy within the inch. And then probably that is very important. Like, for example, like what Kyler said, right? Like if you have to thin it, you have to know where to thin it, and you can't really miss. Otherwise, you just actually thin the whole thing, and really it will be a disaster kind of deal. So I think the standard, the coordinates and all of these formats, which is really GIS formats, which is standard, I think we can utilize, implement that, and it would actually give us the good results. The only thing is more and more people, if they start using it, I think that would be actually beneficial to everyone, so that all these formats, can be standardized in a way that, like at least within the ROS communities, they would start using it, so that we can have more, the interchange and exchange of this kind of data. That would, I'm not sure if that just answers the part of your questions, but that's how I see it.
Yeah, I definitely get the point about having a unified system, but at the same time, I was looking at the cost of it too. And I would assume that's why no one has pursued it, or if they've left it for some reason, but I think that must be the reason why they did that, or it hasn't been explored yet.
I think if we just start using something, it can become a standard very easily. And I do not mean that we need a really complicated standard. The standard could be, here's a QGIS, I don't know what the export format is, whatever that is, or even a layer, a shapefile, even a shapefile that's really well defined. It should definitely be an existing format that is just well defined for our use. By the way, I use UTM for everything. I think in ROS you need to use UTM because everything in ROS is meters, square XY meters. So you need to go to UTM. But then yes, storing data. Latlon seems to be the typical, although as you pointed out, the QGIS will make that conversion very transparent, typically, until you get it wrong, and then it screws everything up.
That's true.
We need to look for a ROS package that takes shape files and makes a ROS map, or puts it in MapViz.
Or, yeah, it seems like there should be a QGIS plugin for RViz or something.
That's unexplored right now. There are a couple of thinking that's just thought process. The MapNIC, it's the one that we may be able to leverage, and the QGIS plugin. If that's possible, it's golden. Just because it's open source, we don't have to worry about the licenses, and it would go a long way. But I don't have any definitive answer at this point that what could work.
What does MapNIC do? Does MapNIC take in shape files?
I think so, but I still need to explore because they're like, and they're really easy too. So, and then it just talks with the Python. It's just within the Python, the whole ecology thing, So that's why I like that. And QGIS, of course, both things that are like they support Python really well.
Yep. I have not done much with real-time QGIS. I was hoping to just start collecting data, pushing it into QGIS, and visualizing it. So I've looked at a lot of documentation, and it looks like that is possible once you hook QGIS up to a database like Postgres. It sure looks like it's possible, but I have not achieved that yet. So maybe someone else will figure that out.
Yeah, no, I haven't looked into that area either at this point. I use QGIS to actually produce the NDVI. So they have this, what they call just a small plugin package where if you provide your NIR image, it would actually give you the NDVI. So I used that a few times. And well, that being said, I modified my Canon camera and then I put in the blue filter. That's what we had for the, I just forgot that. So my Canon camera, I just opened it up and I actually get the IR filter out and put the blue filter in. So now I take the picture, and I can directly use that to get the NDVI. I mean, it's just not 100%, but I think I get the cool NDVI pictures. So I'm happy with that. Because with the blue filter, I get more NIR, and because I remove the IR filter, I get like more of an NIR band in. So I have distinct channels, which I can see red, green, and the part of the NIR. So I think it works well for me. I mean, just with the one camera,
That's cool.
But yeah, I plotted that. I had worked on the end of the project where what it does is actually gets all the images from drone and it stitches all the images together and then converts into the ortho. So we build the mosaic and then you can have the ground control points. You can also lay based on those ground control points, and you can actually take that ortho and then run the NDVI. So you will get the whole NDVI image of your whole farm. Actually, that can be done, and we actually worked on that workflow. So it's working now. We have leveraged the web ODM to do that, which is also the open source software. That project is still under progress, but I think at least you can, with the workflow-wise, what we have done, and this is the part of the university project that I was supporting and coaching. What they've done is you can provide them the image. What it does is actually stitch, converting to the ortho, and then can run the NDVI. So it will give you the NDVI, actually the image of the whole farm. If you have the, let's say 80, 100, 180, 200 images of your farm through the drone, and we can stitch them, convert into the ortho, and run the NDVI. I mean, that's very cool. I mean, it will be off depending on how good your GPS is, but I believe that if you put like about 3 or 4 ground control points, and somehow you'll be able to match those, you would be right dead on, like within about an inch.
I had a talk with one of the presenters today, Mark, who brought a prop back from China yesterday, and it was a handheld nitrogen sensor. And he was talking about it. The idea was you get it down to like $10 for this. And I didn't catch everything, but he was saying that it was detecting shades of green, and that the trend had been to go from 2 to 4 to 6 wavelengths sensors, something. I wasn't quite clear on that, but that they had gone down to 2. They had simplified it. And I'm always fascinated when people do more with software and eliminate hardware. But they were looking at real-time nitrogen sensing, nitrogen level sensing, optically. They're doing it optically. And I asked him about it. He said, oh, yeah, we've got Bluetooth, we've got Ethernet, we've got all these. And I said, I just want serial out. I just want something simple. And he kind of couldn't understand why I would want to do my own. And then I said, look, I want to mount this on a toolbar. And he never even considered it. He didn't. That wasn't even in his thought. He said that was a brand new application. And I thought, wow, how can you not? If you've got a nitrogen sensor, how can you not want to put that on a sprayer bar, for example, or a side dress bar? That's the obvious thing. So anyway, the story is a couple fold. First of all, I think, Sam, you could probably build one of those. I'm very curious what it would take to build one of those, but also this is an example of why if we develop to standards, we could plunk something like that onto a ROS machine, make it a node, and suddenly we're doing something that the manufacturer never even considered, but is really helpful. So I get excited about people writing to standards.
Absolutely, yeah, I agree.
Yeah. For me, I've got a Phantom 4 drone, and it does my NDVI for me. But I need something that can link the information that I get from the Phantom 4. I use the Parrot Square camera. That's the one that is on my Phantom. And it gets all the information which I then get, and I process it through Drone Deploy. They process it all for you, and I need to build a data for all my fields so that I don't go and put money where I shouldn't be putting money. And I think the issue of that data and management of data becomes very, very important. We are now heading into the business, and that is actually very, very important. And I like the idea that Kyla, in fact, your approach to this whole thing. You don't want to be spending money with the drivers in the fields. Let the tractors do their work, optimize software, cut on costs. With all the fighting on prices, farmers are price takers. If you can reduce your cost to the minimum, that would be the best. And I think you cannot run away from NDVI development, where we need to know where exactly do you have problems in your field. Which areas of your field require attention, you know. And listening to you guys talk, I think we'll be moving in the right direction. The raw software need to take a lead and lead us into what each and every farmer will say, well, now something that is useful has come.
By the way, there was a reference today in the presentation, Mark was talking about African farmers, and he said they don't have a lot of money to spend on fertilizer. They don't know what fertilizer to use, and they don't know where to use it optimally to be economically feasible. So rather than put it on suboptimally and waste money, they just don't put it on. And so he was saying that there's this huge opportunity if we can tell these farmers where it makes sense economically to put fertilizer on. It's a huge win for them. So, yep, people are thinking about it.
Yeah, it's most welcome.
It's an interesting discussion. Thanks, Sam, Kyler, for going over that. Interesting. Like there's some good work for us to do, and it'd be exciting to watch all this stuff roll out. Thanks for being here tonight, and you guys have a great week, and we'll see you next week.
Thanks,
Before you go, Matt, before you go, I want to show you this.
Tech demo.
There is my kit.
Oh, you got it from Amazon. They finally sent it.
Yeah.
Congratulations.
That's awesome, Colin.
As always handy.
Yeah. That's the lot. Yeah, I'm getting someone.
Making progress.
Okay, thank you very much. Okay.
Go get it.
Good night.
Thanks, Matt.
See you.
Thanks, Matt.